Hi and welcome to Unit 2 Topic 3 Video 14, and in this video we're going to carry on from where we were last time, looking at just a basic idea of transformations and talk a little bit like I and J from our vectors, so our unit vectors there and what happens to those. Now this falls in line with a lot of our work in terms of the unit square as well, but it is something that seems to just pop up here and there in some questions, so it's worth playing around with. So if we calculate A, B, C, D times by the unit vector I, well, we get this result. Hopefully you can see A times 1, B times 0, so we get A and then C. And if we calculate A, B, C, D times by the unit vector J, we get B, D. So we get the general transformation, but what does this tell us? Well, it tells us that whatever the general transformation is, A, C, B, D, AC represents what happens to the I component, in a sense. And then BD represents what happens to the J component. So there's some shortcuts hidden in here, particularly with very specific questions about I and J components and what's doing here and there. I don't really think it's worth getting into too much depth with, because you can do these the calculations quite quickly in any case. But, you know, it's something you might consider playing around with. Let's have a look at a couple of examples. If the image of the unit vector is under the transformation there, what is the image of 0.37? So it's worth recognising and recalling now that this unit vector 1, 0, that's the I component, which means that the transformation T is equal to 3, 2 is there, and then 2, 5 is there. This is the transformation. Now, of course, you might not remember or recall this process. So let me just stick a little in-between bit here, because the solution is quite simple from there. But the in-between bit could be, oh, okay, we've got some transformation A, B, C, D, and when we multiply this by 1, 0, we get 3, 2. Now, if I multiply that by 1, 0, I get AC equals 3, 2, and therefore A equals 3, and C equals 2. And we just bring that across to here. So hopefully you can see that if you don't recall that you can combine this to make one transformational matrix, that's okay, because it's not that hard to work out just by considering it in the general sense. Go, I'm trying to find the transformational matrix, so let's call it A, B, C, D, and just see where this leads. And as you can see, it leads to something quite simple. So we can do this quite easily. Anyway, we've now got I could do B and D, but obviously I'm hoping that you're okay to cover that yourself. The question says, what is the image of this point, 3, 7? And it's asking, what is the image? So this is the original. So we just get T, and we multiply it by that point, 3, 7, but as a column matrix. So that's equal to 3, 2, 2, 5 times by 3, 7. And that's equal to 3 times 3 and 2 times 7 is 14, 23. And 2 times 3 and 5 times 7, that's 35, 41. So the image is 23, 41. Now it's going to look like everything just blows out of control, but we've got no negatives. And in the examples I've done today, there's no negatives. Once you introduce negatives, you'll find that, or even decimals, numbers lower than 1, you'll find it doesn't blow out of control quite as much. Okay, so that's the end of this video. All the best.